Hello guys, welcome to the Python series. In today's video, we're going to look into the statistics module. So in Python, it is a built-in module that you can use to calculate mathematical statistics of numerical data. So a necessary aspect of working with data is the ability to describe, summarize, and represent those data and visually. So statistics module helps us to create it comprehensive, and it is also popular and widely used tool that will assist you in working with this kind of data. So you can also see that these functions support statistics module also supports int, float, decimal, and fraction. And some of the examples you're going to see in statistics module which you're going to execute today in our video is going to be mean, median, mode, harmonic mean, standard deviation, and variance. So first, in order to start off with the statistics module, let's import statistics as stat. And then we know that statistics is something about mean, median, mode, standard deviation and variance. So first let's start with mean. So let's say stat dot mean, and let's have a set of numbers such as we're going to take 5 comma 10 comma 15 comma 20. So what it does, it just takes all of these numbers by total number of observations. So here there are four numbers by 4. So 5 plus 10 plus 15 by plus 20 by 4, which will give you 12.5. So next we are gonna see what if we have so this all numbers are in pattern, so we get the mean easily. So what if we have one number in the data which is totally off or totally off from the given data? So for example, we have 5 comma 10 comma 15 comma 20, and suppose let's say we have 100 which is totally off. So the difference is it doesn't belong to the pattern. So here we can see a pattern of difference of 5. So 5, 10, 15, 20. So here 100 is totally an outlier which is out of the pattern. And if you want to find the mean of this particular number series, we get mean which is something in between these four, 20 and 100, but it's not the exact mean. So here you can see that 12.5 exactly lies between these both, 5 and 10 and 15 and 20, but here 30 is totally off from the exact mean. So in this case, what we have to do is we can find median. Median is where it is going to take and set, and it's going to find the middle number of the given data. So for example, if you have 5 numbers in this given data, it's going to find the middle number. So here you can see it's 15. So that's what median is going to do. So we have 5 comma 10 comma 15 comma 20 comma 100. So here in this case, it's going to find the middle number, which is 15. And here you can see it's between these two and these two. Suppose let's say we have number which is kind of like not sorted, it's in jumbled form. Let's say it is 10 comma 20, 20 comma 15 comma 5 comma 100. So what median does is it arranges all of these in ascending order. That's what actually median does. It arranges all of them in ascending order and finds out the median. So what it does, it takes them in ascending order 5, 10, 15, 20 and 100 and sorts it out and then finds the median for the given data. So here we have an odd set of numbers, but if we have an even set, so there would be two numbers as a median. So what to do in that case? So we have 5 comma 10 comma 15 comma 20 comma 25. Let's take 25 as an extra number, and 100. So here you can see that we have two numbers in the median stage. So there are 15 and 20 in the middle. So what it does, it takes the average of those two numbers. It will add 20 plus 15, which is 35, by 2, which is 17.5. It just takes the average of these both numbers and gives you the median. So next, what you're going to see is mode. Mode is another term which is used in statistics, which is used to find the most occurring number or most occurring sequence or data. So we have stat dot mode, and let's find the number which is most occurring. So we have 1 comma 1 comma 3 comma 3 comma 4 comma 4 comma 4 comma 5 comma 5 comma 5 comma 5 comma 6 comma 2. So this is a set of data which we have. So in this we have to find which number is occurring the most times, more times. So here if you see 5 is occurring 4 number of times, and it's the number which is occurring the most. So here it prints out the number 5. So the next we're going to see is something known as harmonic mean, stat.harmonic mean. So let us take numbers such as 1 comma 2 comma 3. So, and we're going to find the stat harmonic mean for the given data. So how harmonic mean is done is we have a set of numbers or data which is in the form of a comma b comma c. Let's take it as in the form of a comma b comma c and so on, and it will take the total number of numbers or data by 1 by a plus 1 by b plus 1 by c and so on, right? So in our case, our example, we have 1 we have 1 comma 2 comma 3. So in this case there are three observations or three numbers. So the total number of observations is 3 by 1 by 1 plus 1 by 2 plus 1 by 3. So what we are going to do is 3 by 1 plus 1 by 2 is nothing but 0.5, and 1 by 3 is 0.33. So which we get it as 1.6363. So when we take this 3 divided by 1 plus 0.5 plus 0.33, which is nothing but 1 plus 3 by 1 plus 1.833, then when we divide this 3 by 1.833, we get 1.633. So this is about harmonic mean. So let's print it out. So here you can see that we found out it was going to be 1.633. So here the harmonic mean for 1, 2 and 3 is 1.633. So next we are going to find the standard deviation, which is denoted by stdev in Python. So let's take the same set of values which we had earlier, 1 comma 2 comma 3, and let's find the standard deviation. So standard deviation formula is nothing but s is given by root of 1 by n minus 1, the total number of numbers or observations or data, and sigma I equal to 1 to n. So 1 to n number of observations, and it is given by xi minus x bar the whole square, right? So our data is 1 comma 2 comma 3. So here we can see that average x bar is nothing but the average. So x bar is average. So here we can see that if we do the average of these three, so 3 plus 2 plus 1 by 3, which is nothing but we get it as 2, right? So we get it as 2. So what we'll do is when we take the root of 1 by n, so our n is going to be 3 minus 1. So let's start with xi minus x bar. So it is nothing but 1 comma 2 comma 3, right? So xi, we're going to take the first number 1 minus 2. So 1 minus 2 is nothing but minus 1 the whole square. Then we have 2 minus 2, which is 0. Then we have 3 minus 2, which is 1. So 1, so this is actually plus. So So we get this to be root of 1 by 2 and 2, right? So this 2 gets cancelled and totally we get it standard deviation to be 1. So now let's go find out and print this out. So here you can see that it's going to give us a 1. So let's find out the standard deviation for a different set of values. Let's say we'll take this set of values and find out the standard deviation for this value, and let's say stdev. Here you can see it's 35.41421.5. So this is the standard deviation for the given number. Now let's see about what is variance. Variance is nothing but the square of standard deviation. So for example, we have our initial set of readings, which is 1 comma 2 comma 3, which is 1. 1 square is nothing but 1. So if our value is this, so if you want to find the variance of this, so it's nothing but 35.414 the whole square. So when we take out the calculator, so we'll just copy this and we'll just paste it out here and we'll square it. So here you can see that the variance for this set of readings is 1254.166. So it's nothing but the square of this 35.414. So this is all about the statistics module. I hope you like this video and do like and subscribe to our channel. Thank you.